Hello everyone, in this video we will go over how to graph f prime of x given the graph of f of x. Now keep in mind that f prime of x is the slope function of f of x. In part A we're given this graph where every point on this graph has a y value that represents f of x. Every point that we will be graphing has the y value that represents f prime of x. Notice that there is a special point on this graph, this point, where we have a corner, and at this corner there's no way to identify the slope at this corner. So the slope here is undefined. Keep that in mind. Notice that on the left side of x equals 1, we have a line, and we know that the slope of a line is the same everywhere on that line. So what we can do is we can pick 2 points on this line to find the slope. From this point to the next point we go down 2, and then to the right 1. So the slope is -2/1, which is -2. And again, every point that's on the left side, the slope is going to be -2. So for example, at x equals -1, the slope is -2. Again, these y values represent the slope. At x equals -2, the y value is always going to be -2. At x equals -1.3, the y value is -2. So let's plot those points: -1, -2, -2, -2, -1/3, -1.3, -2, and every point, every x values on the left side of 1, the slope of f of x is -2, so the y value of f prime of x is -2. Now keep in mind that x equals 1, the slope is undefined, so we can have an open circle right here. Right. On the right side of x equals 1, we also have a line, so the slope is going to be the same everywhere on that line, on the right side of 1. So we're going to pick 2 points. I'm going to pick these 2 points to find the slope. Up 1/3. So slope equals 1/3 on the right side of x equals 1. So for example, at the point 4, the slope is going to be 1. At the point 4.3, the slope is 1. At the point of 1.5, the slope is going to be 1. So again, these y values here represent the slope of the f of x. Let's plot these: 4, 1, 4.3, 1, 1.5, 1, and you name it. Any x values has the y value being 1, except at x equals 1, it's undefined, so we can have is an open circle right there. All right. Now let's take a look at part B. We have a parabola, and notice that the tangent line to each point of the parabola are different, so the slopes are different everywhere here. Notice that at this vertex of the parabola we have the slope of 0, so slope equals 0 at x equals -1. So we can plot that point down here where the y value represents the slope of the above function. So x equals -1, slope is equal to 0. -1, 0. On the right side of x equals -1, the graph has a positive slope, as you can notice. Now more noticeably right here, I can draw a tangent line, and I can kind of see that the slope here is up 1 over 1, so the slope is equal to 1, positive 1, at x equals 1. So we have a point for the f prime function. X equals 1, the slope is 1. X equals 1, the slope is 1. Another point that we can pick here is right here at x equals negative 3 on the f of x. Draw a tangent line. Notice that the slope is down 1 over 1, so the slope is negative 1 at x equals negative 3. Translating down here, at x equals negative 3, the slope, which is now the y value of f prime of x, is negative 1. So we can plot negative 3, negative 1. Now, again, if we notice the trend right here, the slope is going to be positive, and it's getting more positive because it's getting steeper and steeper. So the slope function would have a graph that goes like this. On the right side of x equals 1, it gets bigger and bigger. The slope is getting bigger and bigger. The slope of f of x is getting bigger and bigger. On the left side of negative 1, the graph looks something like this.